Respected ma'am, and who are watching this, a warm welcome to my presentation. I'm here to discuss about 8086 architecture. So in this, we are also going to discuss about block diagram of 8086. I'm here to present about this architecture and the block diagram. And my name is because I'm holding up the number of 866. In this 8086 architecture, we have a microprocessor. A microprocessor which have all the functionalities of a CPU. 8086 doesn't have any RAM or ROM, random access memory, or a read-only memory inside it. By replacing that, we are just having a registers. By the registers, we can store the intermediate and the final results, and interfaces were also are located in this microprocessors. In case of 8086, it is a 16-bit integer processor in a 40 pins. These all the 40 pins are just connected to an electrical device or a connected. So here we are observing the 8086 block diagram. So in this block diagram, we are observing and this BIU EU2 divided parts. These are the segmentations, and we observe in this block diagram the segment registers and the instruction queue, and the control unit, arithmetic logic unit, operands, flags, and these we are clearly discussing in further slides. This segment, memory segmentation. Memory segmentation is just to increase the execution speed and the fetching speed. In the 8086 segments the memory. Just 8086 just segments the memory. It 20-bit address bus. In the memory, there are 20-bit address and a 16-bit for the data. And the 8086 works only with 464 KB segments. What are these segment registers? And the code segment, data segment, stack segment, and the extra segment within the whole 1 MB of memory. And the internal architecture of Intel 8086 is divided into two units. We can call it as a BIU and EU. And the BIU is an abbreviation of the bus interface unit, and the EU is an abbreviation of the execution unit. We shall discuss about first BIU, bus interface unit. In the bus interface unit, we have four segment registers, the instruction pointer, a prefetch queue, and an address generation circuit. In the four segment registers, we have again are divided into four parts. And this CS, DS, SS, ES, and the CS means the code segment, and the code segment holds the base address for the code segment. All the programs are stored in the code segment and they access via the instruction pointer. This instruction pointer helps to fetch the data of the instruction queue to the instruction. The data segment register. And the data segment register holds the base address for the data segment. And the stack segment registers hold the base address for the stack segment. Extra segment holds the base address for the extra segment. The further slide is about the execution unit, EU. In the EU, we have the general purpose registers, the ALU, arithmetic logic unit, special purpose registers, the instruction register, and the instruction decoder and flag status registers. In these general purpose, special purpose, and these all comes under the EU. And these general purpose and special purpose are given below. The AX, BX, CX, DX are these all general purpose registers. In the general purpose registers, we have four parts. And the AX, BX, CX, DX. AX means accumulator, BX means base, CX means count, DX means data. These in the slides we have gone and discussed about flags. The flags are again in two parts, control flags and status flags. In the flags, again, we are divided into three parts, and status flags are divided into six. In the control flag, interrupt flag, direction flag. In status flags, carry flag, parity flag, auxiliary carry flag, zero flag, sign flags, over flag. So ALU and special purpose registers. In the ALU means arithmetic logic unit. All the logical process or operations are made in only just ALU, arithmetic logic unit, and the 8 and 16-bit arithmetic. So special purpose registers are stack pointer, base pointer, source index, and destination index. We just discussed about the general purpose registers like AX, BX, CX, DX. Now the further registers are special purpose registers. And the stack pointer points to the stack top. Stack is a stack segment used during instruction like push, pop, call, or AT, right? And the base pointer can hold offset addresses of any location of the stack segment. It is used to access random locations of the stack. Source index. It holds offset address in the data segment during string operations. And the destination index. It holds the offset address in the extra segment during the string operations. And this What are the offset registers? The offset registers are just used to find it out the physical address, like segment registers into 10H plus offset registers. The control unit. Control unit just uh, translates the machine instructions into control signals. That's part of a control unit. Thank you for giving this opportunity.